Yeah, right? I'm like, Miss Green, what do you think she's gonna have to do? Oh, no, talking about the toe? That's awful!
Robert. Hi, Joyce. We're just starting off. They wanted to ask a couple things about the worksheets. I'm going to go find it real quick. And they didn't know where the solutions were online. So I'm showing them that too. Otherwise, we're going to start, I told them, section 9.1 today. Finish it on Monday. Homework due on Tuesday. It's a pretty easy section to start. And then it gets very important for Calculus BC at the latter half. So, things to keep aware. I'm going to be gone. You'll probably hear it in class too. But next Thursday and Friday. And we'll figure out life as far as what's going on. So that's good. Back to the worksheet. Okay, so it was just in your class folder. Okay. It was just in your class folder where you guys found the... Oh, no, I gave it to you, didn't I? I gave you a shortened version of the handout with just the first page of problems and then the first page of answers, but I didn't print out for you guys handout assignments. Even though I showed it to you on Wednesday, I didn't print out all of, the solutions. So, here they are. Oops, keep going. All the sample problems have completely worked out solutions. So, yeah. Alright, so which ones did we have issues on? Let me go back to the sample problems. We might not do all of them, but if we could do a couple, it's not a bad idea. Let me go here, let me go here, let me go here, let me go back, and camera. Alright, Amanda, which one?
I think I'm good enough. I'm looking at the Texas problems and they're making more sense for her to switch them back because they just...
Use the triangle, right?
Yeah, I figured out how to do the triangle, but my answers weren't matching up, and now that I looked at this, what they did is they just, took the 2 out of the entire denominator and made that minus.
Oh, they were, simplifying stuff. Okay.
So that's why my answers didn't match up. So
Okay.
I think I'm good now.
Does anybody else want to see anyone? We could do one, but if you're good, we'll just keep going. Yeah. Let me get rid of him. I'm going to keep this open just so we can check the answer when we're done. Okay. So then checking out number 6. All right, kiddos, according to the form, how would you think about going about number 6?
I might get a common denominator at the bottom because you could do something like that with the x squared.
Wait, common denominator? It already is one piece, right?
No, since it's x squared plus 9.
Oh, try use that? Is that what you're thinking?
I was thinking do u sub because...
Because then you have the 2x, you can deal with 1, you have 1 additional x.
Yeah.
But then you would end up with u squared minus 9 square rooted. You're not going to really change it much, sadly. You could do u sub. But technically, we could also look at this and say it doesn't perfectly fit an inverse trig. U sub 2x doesn't perfectly fit. There's a square root. Hey, this is one of those Pythagorean trig sub ones. Do you guys know which one specifically?
Yeah. It's going to be... The hypotenuse will be... The hypotenuse will be the square root of x squared plus 9.
Yeah.
And you're using the opposite of base function. So u equals...
Because u equals a tangent, right? So then 3 is going to be down here. X is going to be up here.
You're not supposed to use sine, right? Or no? You are.
Not for this one. With the plus, you want to use tangent. Let u equal a tangent of theta. So we can say that by u I mean who's squared, so x. So x is going to equal 3 tangent. Does that make sense? Opposite over adjacent. Move the 3 to the other side.
Yeah.
So x is equal to 3 tangent theta. So when we come over here, remember trig sub, the whole point is to sub in, yeah? So then on top, x squared is going to be, plug in 3 tangent squared, so 3 tangent quantity squared, which will be 9 tangent squared of theta. And the denominator, well wait a minute, what could I set equal to this if I wanted to do trig? I could go plug in this into the square root, but that's messy. I could also say, hey, he's right here. Use the constant, because that's easier. Who's equal to hypotenuse over adjacent? Which is the flip of adjacent over hypotenuse, secant, good. Chosha, right? Chosha cow. So then we have square root of x squared plus 9. We can move the 3 to the other side, right? So we'll have 3 secant theta.
What is it called?
Huh? Cosine is 3 over, so this over is secant, and then we just move the 3 to the other side.
What are you saying? Why does that help us? Is that what you're asking?
Yes.
Oh, because then we can just plug in. Otherwise, we have to plug in tangent squared plus 9 and do some, like, transforming. This way we can just go straight to the trig, which would be 3 secant.
What the heck?
Does that make
Life
sense?
is so much easier.
You can use your triangle. Do they make it harder?
Yes.
Yeah. They plugged in the X in.
Oh, everywhere without stink.
Yeah.
I'm calling it right now.
That makes
Schmuck.
more sense.
Yeah, I use this triangle as much as possible. And remember, we can't change the dx until we find it legally, right? So then we'll have 3 secant squared, theta d theta. I mean, you can do it the other way. You're just going to have to use your properties in order to transform stuff, which is messy.
You're telling me.
Yeah, sorry.
What did you get this one?
Derivative of tangent. So I'm taking my x expression, kind of like u du, and I'm taking dx. Derivative. Oh. So then I can go ahead and 3's cancel, right? Secants reduce. So I just end up with 9 secant theta, tangent theta, no, tangent squared, sorry.
Misty,
Yeah.
you want to know what added insult to injury just now?
Uh-oh, what?
She kept saying secant.
Oh. See, I didn't like how she said things, like, hi guys. But, besides that. But that's okay, that's just judging, so we need to stop that. We could choose u as tangent, but that would be secant squared, that's not good. We could choose u as secant, but u as secant tangent, that's not good. I'm pretty sure this is going to be another integration by parts, right?
Secant squared minus 1.
Yeah, we can make it secant squared minus 1, but then with secant cubed, we're going to have to do integration by parts again anyway. True? So then instead, I would think, let me change colors just so you can see my integration by parts, but I would think let u equal, well, dv, what can be integrated? Tangent squared? No. Secant tangent? Yes. So use as much as you can. Does that make sense?
Oh yeah, and tangent drives to secant.
Yeah. So it's very similar to secant cube. I mean, we're going to have the same dealio, basically. Because that's going to be secant.
This is much easier than what I was doing.
Yeah, you just have to play with. I mean, this is a hard one in the sense of you have integration by parts, but I'm going to be lazy for a second because I'm tired of the mouse. Don't worry, Mrs. Christensen's working on other options, I think. I haven't seen her today, but just we're not there yet. Make it a squared. We have our d theta. Then we can do our lucky number 7 with uv minus v du. So we have our secant tangent. Minus the integral of secant cubed.
We still have to erase the
No, not exactly. Because didn't you notice on yours, Gerardo, that we could take a secant squared and make it 1 minus tangent squared? So we can separate secant from secant squared.
Oh, yeah, you can do that.
And why am I doing that?
I don't know. Because tangent square is kind of hard to integrate. Wait, isn't it? Yeah, kind of is.
But then I can make this minus the integral of secant theta, which I do know, right? Plus the integral of loopy. What's loopy about it? Nope, but close. What's loopy about it?
You can subtract it over and you'll get an 8.
Yeah, look at the original. The original is what I'm trying to find the answer to, right? So I can take that, I can group that, I can squish them down and say, fit. These two match. So I can subtract him to the other side, which is going to end up with an 8. I can divide by... Oh, wait a minute, hold on, but I want to solve for him. How does that work?
You divide by the 8.
No, but I don't want to stink. I want to solve for the 9.
Why would you want to solve for the 9?
The 9, you can just take.
Yeah, can't you pull them out with multiplication?
Yeah.
Yeah, you subtract it, now it's an 8. And then you just divide the 8 over and you have the integral equals all that over 8.
And then multiply that by 9.
No.
Wait. Do you guys see what I'm saying?
No. Can't do it. Yeah.
Because we're solving for 9 times. So the final answer, I don't want it to be for secant tangent squared. I want it to be for 9 secant tangent squared.
Yeah.
So when you solve and you divide by 8, you're solving for 1 secant tangent squared. I need 9 secant tangent squared. See what I mean? Usually we don't have that 9 there. So then I think I'm going to end up with, it is going to be minus 8 divided by 8, but then times 9. So we could do 9. Is there a way to actually show that though? Oh, times 9 over 9. I could do that. Okay, whatever.
What you could have done is like pull out the 9 early, integrated it, and then bring it back in later.
Or like had it all along the way. I didn't put the 9 in here, that's why I got confused. Okay.
No, like if you'd had it, if you pulled it out and just integrated secant tangent squared, you'd have had like something different. It would have been like.
Well, I did just integrate secant tangent squared. I didn't integrate with the 9. If I had had the 9 in there, it would have worked out okay.
Then. Yeah.
Okay, so I'm going to end up with divide by 8, 1/8 secant tangent. Just pretend I put my thetas in, because I got lazy. And then minus, we know the integral of secant, hopefully.
Absolute value.
Yeah.
Secant plus tangent.
You guys see what I mean by times the 9, right?
Can't you make it 9/8?
Yeah, so I can go ahead and throw my 9 in and say, but that's who I wanted, and then we can do, okay, fine, so that's going to be there, and that's going to be there. There we go. And 9 times the constant, no big dealio. Anyway, does that help seeing me solve one?
Yeah.
Okay. So I use that triangle as much as possible, but the one thing that she did try to hit home with is these different forms should match you to different places. If you see the plus, that should match you to arctan, or I should say to tangent. If you see the minus with the number going first, that should match you to sine, right? Yeah, sine. And then if you have the variable going first, that should match you to secant. Anyway. And that is shown if you guys still look, I know that all of our examples aren't worked out, but if you go back here, that matches with what we see here. With one form goes, and then one form goes, and then one form goes. But I use these triangles more than I guess the solution manual did, and I apologize for that. All right, are we cool?
For the last one.
Yeah.
For when it tells you what square root of u squared minus a squared equals, can we on one side involve u equals a secant theta? Can we make our lives simpler, I guess you could say. But
Ultimately, when you go to plugging in, but don't do it yet because we want the variable to be solved easily, so we don't want to use cosine or else we'd have a nasty division. I mean, I guess you technically, when you go to plug in, yeah, I like cosine better too. But depending on the situation, if you have tangents, you better stick with secant. Does that make sense?
Can we just plug in into x, sub in for x, because memorizing when to use a tan theta.
Oh, yeah, well, you don't need to memorize any of these technically. It's more of just a general understanding of what trig sub is, when it's useful, and in general, how you do it. Does that make sense?
Yep.
But yeah, I would plug in. I wouldn't memorize either. Okay, let's go ahead and go find section 9.1. If you guys have your worksheets ready to go ahead and turn them in today, but I realize today's examples might have been helpful, so if you guys want to wait and turn in on Monday, I don't mind either way. Just make sure name is on it. I just need sample problems, odds, done, ready to go.
I have it on separate piece of paper technically.
Yeah, because the worksheet was a separate piece of paper. I didn't make you do it in your spirals. Unless you did. Did you guys do it in your spirals? Okay, I didn't think so. So if it's ready, go turn in the tray. Otherwise, you guys didn't turn in your forever quoting or bonus exams yesterday, because I just didn't want Senior to have to worry about it. Oh, Jordan, in the back, sorry. You guys are on the
I don't know, I'm over here.
left-hand side middle.
Right, nice.
So go ahead and grab out your forever endeavor quoting. Technically due yesterday, but now it's due today, forever endeavor quoting. And also bonus exams if you did it, on top. And go ahead and throw it on top, back with Gerardo, and then the worksheets will be due as well. But the worksheets I'll take until Monday. Do you want paperclip, kid? Might be easier.
Yeah, probably.
Sam, can you pull open the drawer right above where your knees are? Yeah. And on the right-hand side, there's a big box of paper clips, the bigger box. Yeah. Thanks, Sam. Otherwise, we're starting 9.1. Oh, wait, your Forever Endeavor quizzes.
Oh.
No. Sam, can you bring me the little pile? See the half sheets of paper? Bring me the little pile, right behind the bananas.
Apparently Joyce got
In front of the bananas.
What?
Really?
Yeah. Yes, oh well. You saved her own. Actually, both piles, yeah, I'll take all of them.
Did you figure out my writing?
Yeah, I just kind of guessed a little bit.
Sorry.
I just guessed.
George's was mean. He had
two polar parametric.
yeah, he had a polar
Grab out a colored pen.
and polar I like semi-guessed.
X squared plus Y squared.
Grab out a colored pen.
No. Polar derivatives.
Oh, that one is like R plus some plus cosine.
Yeah, I know. I had to like think I got it. I wasn't sure if it's
Which
practical.
Whoever's like grade, I got purple. Oh wait, we're grading our own, the ones we
You're
made.
grading the one you made.
Makes sense.
That way they couldn't have randomly changed the answers. Whose is this? Manny Devassarian. Gerardo. Georgie. We have Joyce grade one still. There we go.
Well, Joyce has her own to grade.
Amanda Johnson.
No, she can do it.
Oh wait. Where is? Oh, give that one to Jackie, because this one is Jackie's.
Haha.
And Joyce, I need to figure out where she turned hers in.
Probably put in, Brache probably put in the 6th period.
Oh, it's probably true.
Oh, Brache.
Alright, if you guys want to get out your cards or open up your phones, each problem is worth 2 points. If you think what they have is valid of half credit, meaning like they got the conditions but not the conclusion to a theorem, they missed it by a negative or a sign. They forgot a U prime, but they got the rest of it, etc. You can take off just -1. Give me a final score out of 10. Oh, there it is.
Vicky?
Yeah.
Should be the same. Instead of R squared equals A squared plus B squared, it can be X, or instead of X squared plus Y squared, it can be A squared plus B squared.
Can I give you choices, George? Is that okay?
Yeah, you can.
I found it. Just took me a while.
If
If you have a question, let me know. Otherwise, you're giving a score out of 10.
I think we all just graded by memory.
Perfect. That's a good thing.
Yeah.
Well, I didn't know the one I gave you for number 2.
Which one is that?
Take off 1.
Oh yeah,
And be
I knew it, but I didn't know it.
The only thing is
Like, I know what it is, but I don't
instead
want
of
it.
f times x squared.
Minus a half? Minus 1, because it's a 2 point.
Oh. So it says.
Then your overall score will be for the quiz that you made and graded. Hopefully you did it right, which I bet you did. Half that, and then half how you did on the version that you got. Just in case you got a hard one.
Amanda, 100%.
Misty, do you know what today's pep rally is about?
Motivational speaking.
Is it the one that they
I
did
don't.
last
I honestly
year?
don't know. Someone just said something about. Did they do one last?
Or was it last year? The one where like that dude from Shake It Up came?
That was freshman year, wasn't it?
No, I think it's like.
Oh, that was sophomore year. That was
That
sophomore
was
year.
so bad.
I think it's the administrators.
No, that was like a full-on chapel.
Yeah, that was a
Chapel,
full-on
I thought it was
chapel.
a chapel.
Wait,
Yeah.
who's the guy from Shake It
The-
Up?
Kenton Duty, is that his name?
Yeah,
Yeah, the
the
blonde kid.
blonde guy. He was like the weirdest one.
Yeah.
I mean, I'm sure you went over well
I
with the middle
remember
schoolers.
that. Okay. 'Cause
That
I
was
wrote it on
sophomore
the
year.
He
Snapchats.
had bracelets and
All right, kiddos, notes open. You can start writing down section 9-1.
I agree, that one was weird.
that was the best one.
That was the worst
The
one.
middle
It was, like,
schoolers,
supposed to
I'm
be
sure,
about
loved it.
bullying
Come
and
on,
then,
you know
like,
they
it
did.
had to do
Just
with nothing.
not necessarily the high schoolers.
And then Matt screamed.
There were a few high schoolers that were excited.
Yeah. Excited or mocking?
Well, there was plenty that was mocking.
Yeah.
Number 5. This is what I was trying to base it off of, but no.
Is there a built-in bonus?
Kind of. Like you get 100% just for making a quiz and grading the quiz, right?
Oh, okay.
So it's going to do like an average of the two.
Alright. Do I have to grade Joyce's if she did her own?
Is it hard to grade? I can. We'll figure it out. Yeah, yeah.
Because I think she got 100%. I don't know.
I can peek at it.
Theoretically.
But you have to like figure out where they are and stuff.
They look right. They look very in depth.
Oh yeah, she went all out.
Are we glad we didn't get her test?
Probably.
Thanks, Joyce.
Well,
she
it
had
was similar to
rules.
some years though. She did like arc length and an average value, integration by parts. So it was similar. And then she stated rules.
I hate rules, dude.
Because there's 3.
That was my
Oh,
favorite.
that one's
Oh,
my favorite.
I like
And just because like even though it has like one more condition, the condition's not hard to remember, but like it's just F prime of C equals never mind.
0.
0. There you go, 0.
Yeah. As opposed to MBT where you have to do
Yeah, F prime of C equals F.
F of B minus F of A all over B minus A.
But like, my problem is, it's like, I don't understand it came first, but when it compared to MBT, it's like.
It's a more
it's
specific.
corollary.
Well, now, if you don't think about the historical
Yeah,
context.
that's the problem.
But we try to think about historical context at some point.
Yeah. But what sounds cooler? Rolls theorem or rolls corollary?
And it is like horizontal tangent lines, like it's not a horizontal tangent lines, what's the big deal, but it's when the velocity is 0, stopping points, like we do a lot of specific cases, you know what I mean? Or like x and y intercepts, whatever, it's another point, but they're particular to the case at hand. Okay. Ooh-hoo-hoo-hoo! Look at us going back.
Also never learned how to do that.
Good thing we're reviewing then, never mind.
I learned,
Parametric,
but
polar, and sequences. Don't know at all.
Don't know it all. It's gonna be a party.
Yeah.
Thank you.
I have to find. I saved all my pre-cal notes, my calc notes.
Just to
but
find
I
them.
have no idea where they are. Like I have half of them. Like
Where'd
I have
you
first
put 'em?
semester of pre-cal. I have first semester.
Oh, I have random
of
notebooks
calc.
in my filing things, just in case you left it.
I don't know.
Oh, yeah. I have my hard copies now, so like I put them in this folder,
The doctor was mean, and so was Madame. I'm trying to be good.
Wait, what?
The doctor was like, no way, whatsoever. I'm trying to be better. Okay. So I don't want to write over there. It's annoying. It takes forever.
Why don't you just sit on the chair, or is that harder? Or the stool, because it's a little higher up?
Then my foot's That's I got it. I'll just be like rowing the chair. I just won't do it for the next period because you're gonna laugh. You guys can too. Find the first 6 terms and the 100th term of the sequence. What's going on? Who is this formula up here with n's?
Put in the n and that gives you that number.
Yeah, basically, sequences and sums, they usually have an n for being the nth term of the sequence. We'll look at the sequence. Sequences are separated by commas, series are separated by pluses because it's a summation, which we dealt with somewhat last year with Riemann sums. So if we want to find the first 6 terms, we're assuming that n starts at 1. Sometimes n does start at 0, like the 0th term, kind of like in physics, when time is 0. That would be the initial. But, get closer to the board. Okay. If we plug in n equals 1, what do we get?
2.
If we plug in n equals 2, 3 halves, but 3 halves squared, 9/4, right?
Oh, I forgot.
Double check my math.
I didn't write that down.
1 1/2, 3 halves, 3 halves squared, 9/4. Good. Plug in 3.
1/3 plus 1 is 4/3.
4/3 cubed. 64/27.
Yes.
Wait, are we trying, for 6 to...
Now, just for sake of time, so you can see, I think I actually stole directions from another problem. You can see this is getting kind of big, kind of fast, so we'll just slow down. But to find the first few terms, plug in n is 1, n is 2, n is 3. Up above, sequence is a list of numbers written in explicit order with some sort of pattern. Usually some sort of pattern. Some simpler, some harder. We're just looking at simpler ones today. How would we find the 100th term of the sequence?
Plug in 100.
Yeah, so it'd be 1 plus 1 over 100, which would be?
101 over 100 to the 100th power.
Yeah, and we'll just leave it there. But technically,
What numbers he saying?
unless they say anything specific about like an ending point to the sequence, what are all sequences? Infinite. However, does that necessarily mean they're always, that the terms are always expanding? No. For instance, can you guys tell what the terms of this sequence are converging to, because this one does converge? Not 0. 1. Why? 2 goes down to 3/4, right? Because that would be 2 and, oh, it goes up? That's good. It starts by going up, 2 and 1/4. And then 27 over 64.
Because it's
Would be
to the power, that's what I found convergent, is that divergent?
Yeah, it's divergent.
Because of the power.
If the one,
But 101, let's say we were to do 1,000, right? That'd be 1,001 over 1,000 raised to the 1,000th power.
What if we would do 101? 101 over 101.
I guess it'd be 1 to the infinity. Is that indeterminate? 0 to the infinity is indeterminate. 1 to the infinity, isn't that 1? We haven't gotten to low details yet, have we?
Well, it should be on a budget.
yeah, it should be in the look
So we'll see if 1 to the infinity is indeterminate.
Yes,
If it is, then we might.
It is,
Stink. Okay, then maybe it's not converging.
yeah.
Sorry, I was focusing on the art being raised to the power, but maybe it is diverging. Anyway, this introduces us to, these are gonna be fun. And this introduces the main other part of Calculus BC. There's vectors, which you guys kind of saw in your Christmas bonus exams if you did that. But the vector stuff is actually really easy, and then there's sequences and series. And Taylor and Maclaurin and polynomials and stuff.
power series?
Okay, so we know how to plug into this one. This is called defined explicitly, because we plug in 1 for the first term, 6 for the 6th term, 100 for the 100th term. Easy cheesy. How about the next one, defined implicitly? What's going on?
Pain in the neck.
What? Why? In some ways it's easier.
It's the same thing, pretty much. You just put them
Except, what's my first term?
in.
3. What's my second term?
You have to find out.
3 minus 2. Oh. What's the next term? 1 minus 2. Why? Because the
That's
pattern
right.
is to find the next, you take the previous and subtract 2.
Yep.
So minus 2, oh, this is easy, right? Negative 1, minus 2, find the 8th term. Can you jump there?
No.
That's why it sticks. So I have to say, okay, the 5th term would be minus 2, negative 5, negative 7, negative 9, negative 11. No big deal, unless I was to ask you for the 100th term. Oh, it's a big deal now. Unless we use something that we have called a computer.
Or
Why? Because with programming, you can make a computer do lots of repetitions
Really fast.
in very short amounts of time, right? Isn't that the key to a lot of algorithms that computers do? Or use in their programming? Okay. 2 special sequences, arithmetic and geometric.
Which
Which
is
is more comfortable?
was it
Arithmetic or
easy?
geometric? Huh?
is there a third? I forget if there's a third one.
No, the third is just neither. For the answer options of the
the worst ones is when they give you like the first term and then the 5th term.
Oh
I
yeah.
want you to find like the 3rd term.
That's not coming on the next page. Okay, so.
I hate that one so much.
Yeah, those are pretty creative thinking ones.
I like those ones.
You have to jump and then you have to like
Make
melt
the
them.
jumps, the number of jumps, and make your own formulas.
It's so
No, like
Man,
I knew how to
like
do it, but I
that.
forgot for the
Yeah,
final.
I'm excited for this.
That's good. Plus it fills in holes from before, so that's good.
I love learning this because Crawford didn't teach us this.
Yeah, it was something.
Well, we
Because he taught us like series and
Sections
sequences.
and stuff.
Yeah, but he didn't teach us like, oh, there's a special way. We just had to figure it out, which is really annoying.
Well, I mean, for some, that's all you got. But for arithmetic, geometric, it's okay, what are you noticing when you're writing down about arithmetic sequence? Although Ryan Murphy says it should be arithmetic. That just sounds like therapeutic, I don't know, like something
But
medical.
there's an E, there's no A.
He still thinks it should be arithmetic.
Well, tell him that next time you see
Ryan
him.
Murphy.
I guess more of an adjective than oh well. These ones, each term is obtained recursively. Uh-oh. Recursively, that means the jumpity jump jump jump, right? From preceding terms by adding a common difference D. By adding a common difference D. So someone, without looking at the one below or without stealing the one below, what would be an example of an arithmetic sequence?
1,
plus
3,
one.
5,
Not plus, not plus, we're not considering yet. 1,
3,
Oh. Well,
5, 7.
all the odd numbers, yes, but
What?
why is it an arithmetic sequence?
Because you add 2.
Because there's just a common difference, that's a term, of add to, add to, add to, add to.
Could it also be subtracting? Oh, I guess D could be negative. Never mind.
yes.
Subtracting, no, because we always move from left to right, we always move up. First term, second term.
No, like it could be 1,
Like
negative
D,
1,
the D
negative 3.
differences. The common
Oh,
difference
could
is
it
negative.
go with a negative, yeah, it can't go with that. So what if I was to ask you for the 7th term, what would you do?
You gotta plug them all. Well, not really.
Keep on jumping, jumping, right? You could. So the 4th term is 7, so then
9, 11.
9, 11, 13, right? If I was to ask you for the 100th term? Think of a formula. Why?
That's what I was
Because you're jumping by a constant every single time. So we know from math how to simplify repetitious activities, right? We could take, in order to get to the 4th term, we could do 1 plus 2 plus 2 plus 2. Oh wait, 1 plus 2 plus 2 plus 2. Couldn't we say 1 plus 2 times 3? Right? To get to the 7th term, what could we do?
1 plus
2 times 6.
Yeah. So let's be amazing and say, wait a minute, we got this then. To find the 100th term, what do we do?
299.
Got it.
Dude, 99 is a scary number.
That's after I said that.
198 plus 1, 199? 100th term.
Cosinos.
Does that make sense?
Mm-hmm.
So special sequences are nice because first arithmetic and then geometric, they have a constant change from one term to the next, and so we can actually show that, in this case, repeated addition with multiplication. or with geometric, we're gonna be able to show repeated multiplication with exponents. Gerard, go ahead.
With this one,
Okay, so now we're looking at the example, hold on, let's transition. Where they give you a sequence, the first four terms. And they're asking, well, they're saying it is an arithmetic sequence, what is the common difference?
1/2.
1/2. Adding 1/2 every single time, right? So you can say the common difference, d equals 1/2. The 8th term, well, I don't know, theoretically, maybe it's easier just to jump there. If you could jumpity jump, jump, jump. Oh, but that'd be quite a few jumps, right? So what can we do instead to get to the 8th term?
Think about it.
If it's the 8th term, how many jumps of 1/2?
7?
7. 7 halves plus 1, 2 halves, 9 halves, right?
Yes.
And then based on what we've seen, we could do a recursive formula or rule and explicit, well, similar. Kiddos, start homework not due until Monday, but for those of you especially that didn't do sequences in pre-cal, you might want to check it out just so that you're kind of more ready on Monday.
Joyce, if you like this video, like, subscribe, leave a comment, description below.
I don't care though.